Good evening, viewers. Welcome to my channel, Second Math Hub, the solution to your math problems. Still on trig, but this time I want us to look at angle of depression. So this is our first question. Question 1. A cliff is 102 meters high. A cliff is 102 meters high. So that is the height of the cliff, 102 meters. From the top of the cliff, the angle of depression of a boat is 27 degrees. Find the distance of the boat from the foot of the cliff. And we should also correct our answer to the nearest meter. So quickly, without wasting my time, let's represent this information on a diagram. So there is a cliff. So a cliff is a highland whose base is embedded inside the sea. So this is the whole of this line here represents the sea. The whole of this line represents the sea. And then we have a cliff. So we have our cliff. And then we were told that the height of this cliff, the height of this cliff here measures 102 meters. So meaning that this is the height. That is the height of the cliff, 102 meters. Then we were told that there is a boat in the sea. So this is our boat. We have our boat on the sea. So this is our boat. This is our boat on the sea. And then the angle of depression from the top of this cliff, the angle of depression to the boat measures 27 degrees. So how do we draw the angle of depression from the top of the cliff? So if you remember the introductory video to angle of depression and angle of elevation, before we measure the angle of depression, there must be a horizontal line of sight. So this is our horizontal line of sight. And the angle below the horizontal line of sight is what you call the angle of depression. So you can revisit the introductory video. If you have forgotten angle of depression. Okay, so we said that the angle below the horizontal line of sight, is the angle of depression. So where do we place the 27 degrees? So this is the angle of depression. This is the angle of depression. So now, what are we supposed to do? We have to find the distance of the boat. The distance of this boat from the foot of this cliff. We have to look for this distance. This distance is what we have to look for. So clearly, we can transform this diagram into a right angle triangle. So let's do that. Let's quickly transform this diagram into a right angle triangle. So this is our sea level. This is the cliff. So obviously we see that the cliff will meet the sea level at an angle of 90 degrees. So let's take note. The cliff will meet the sea level at an angle of 90 degrees. And this is our horizontal line of sight. And the angle below the horizontal line of sight is what you call the angle of depression. So 27 degrees here, that is the angle of depression. And again, we were told that the height of this cliff measures 102 meters. And then there was a boat here, a boat on the sea. So I'm naming the boat as point B. So even before we start with the calculation, let's name our right angle triangle. So I'm naming it as ABC. ABC. So now, how then do we calculate this distance? Because that is what we are looking for. We have to find the distance of the boat from the foot of the cliff. So this distance is what we are looking for. So let me represent this distance as x. So the distance between A and B, I'm representing it as x. But from what we have done so far, before we can identify the sides of the right angle triangle, there must be an acute angle inside this right angle triangle. But as we can see, there is no acute angle here. The acute angle that we have seen here is not inside the right angle triangle. So how then do we get an angle inside the right angle triangle? So if you can recall from plane geometry 1, angle properties of a parallel line. Anytime you have parallel line, and then we draw a transversal. So a transversal is a straight line that cuts across two or more parallel lines. So this is a transversal. So now, if we have here to be 27 degrees from alternating angles, So alternating angles are angles that are formed from the alphabet C, as you can see. So if this angle here measures 27 degrees, then this side here must also measure 27 degrees. So in conclusion, if this angle here measures 27 degrees, then this side here must also measure 27 degrees. So we now have an angle inside the right angle triangle. So now let's identify the sides. This side here is our hypotenuse because it is the longest side. Again, to the side facing a 90 degrees angle. Now, which side is this? Talking about the height of the cliff. That should be the opposite. Simply because it is the side facing the acute angle. So this side here becomes the opposite. Then obviously the remaining side will be the adjacent. So now we have our opposite, we have our adjacent. So from SOHCAHTOA, which of them has opposite adjacent? So clearly that is TOA. So meaning that to calculate this distance, you must go by TOA. And then TOA says that, so from our triangle, so how do we name this triangle? So we can name it triangle ABC. So the tan of this angle here, 27, must be equal to the length of the opposite. So in this case, the length of the opposite is the height of the cliff, 102, divided by the length of the adjacent, which is x. Tan 27 is the same as tan 27 on 1. So we can cross multiply. So x times tan 27, x tan 27, and then 1 times 102. 102. We are looking for x. So we can divide both sides by tan 27. Here by tan 27. So tan 27 will cancel out, leaving x is equal to 102 divided by times 27. The rest is calculator work. The rest is calculator work. So from our calculator, what is 102 divided by 27? So I'm having 200.19. That is to 2 decimal places. And then don't forget that we were told to correct our answer to the nearest meter. As you can see, the nearest meter. So let's correct this distance into the nearest meter. So this is the whole number. So that should give us 200 meters. So in conclusion, the distance of the boat from the foot of the cliff measures 200 meters. Thanks for watching.